welcome to the return of Sunday Science Q&A. We've been away since we did the 25-hour live show, which some of you might have seen. Some of you might have seen all of it. Some of you might have seen some of it. Some of you might have been those people who were very busy conversing in the chat room, which was a lovely thing to see. First thing I'll tell you is that all of that is now online. Robert Smith, Jocelyn Bell-Burnell, Tim Minchin, enormous number of scientists and entertainers that you can find all of that there. So anyway, Happy New Year, or reasonable new. It's happy almost feels like it's pushing it too far this year, doesn't it? It feels like just some basic level of occasional contentment during an afternoon will be enough, but I'm going to push it for a Happy New Year anyway. I have a few announcements before we start. Today's show, by the way, is all going to be, well, most of it will probably be about the sky, most of it the sky during our period of night, but it will be about other things as well. We've had lots of questions in. Thank you, everyone who sent those questions. Also, if you have questions that come up during the show, as this is live, you can either tweet at, well, in fact, actually, that's the best thing to do, is tweet at Cosmic Shambles, or go into the kind of the chat box underneath this, and we will try and deal with any questions that come up in the next hour as well. And we have a great panel with Helen Czerski, who's of course with us every single week, and also this week we have Professor Lucie Green and Professor Chris. Professor Green, you are a professor, aren't you, Chris?
Yes,
yeah,
it's okay. You can just call me Chris, Robin. It's fine.
No. But I wanted to give everyone their titles this time. It's just that you don't dress like one of the professors that I see in the TV series Endeavour or Morse, but no longer Lewis, sadly. I will tell you a few things, a quick couple of announcements as well about what we've got coming up. We've got a lot of stuff coming up in the new year, including a new series which is probably going to be called Cosmic Conversation, which is a very, very kind of simple and reasonably banal title. But behind that banal title, each week I'm going to be having a conversation with predominantly scientists and astronauts, but also other people as well, about finding meaning and purpose in a universe which appears to have no overall meaning. And I'm going to be talking to people like Tim Minchin and Brian Greene and Sarah Parkak and Andrian. And one of the first ones I'm actually going to be doing, we have, well, I'll tell you about that in a minute, actually, because I'll give you an announcement because you can actually watch it live. So I'll tell you about that at 2:00 on Tuesday. I'll tell you all about that shortly. And also on Tuesday night at 8:00, we're doing the first of a series called The Reality Talks. I'm going to be talking about physics, death, and ghosts, but not necessarily in that order. To be honest, I'll probably leave physics to last because that really is probably one of my weakest. I'm much better on death and ghosts than I am on physics, and that's at 8:00 on Tuesday. And you can watch that live. In fact, the only way to watch it is live, and you can get a ticket for that, or if you're a Patreon supporter, you get free access to it as well. And I'm also going to be joined by a fantastic paranormal investigator as well. And again, I'll tell you more news about that shortly. And that's pretty much it to begin with. So let's get started. And we're going to do show and tells as usual. Helen Czerski is going to have something different. We're not going to see it immediately, but Helen, can I just ask you, what are we going to have from you today?
It's history with context. I think that I don't know. I mean, I feel we should leave it as a teased thing. Although there is also a topic, we might dip into a topic that comes back many times to haunt me, which is all my fault this year, and regular listeners will know what that is. But yes, that in the middle of the show.
Basically, what's happened, for those of you who don't know, is because we've been doing these now since whatever it was, April, and every week it's been a show and tell. And Helen doesn't have a huge flat, so she's actually run out of things in her flat to show and tell. And so we're having to. But our other guests, who we have not had on quite so often, do have a show and tell. So Chris Lintott, there's a lot to talk about you as well, because on the 25-hour show we had Search for a Supernova, which was very, very exciting. I really enjoyed that. And were you happy with how that went down?
Yeah, we've been busy ever since. So we challenged the viewers to go and try and find a supernova via our Supernova Hunters project, and they've just kept going since the show. So since then, more than 300 potential supernovae have been found by Cosmic Shambles viewers, and we've reported them all to the astronomers of the world, and people will be following these up. On the night, we managed to get a Type 1a supernova, which let us measure the age of the universe, and we adjusted it very slightly. But actually, the system works, and we've had people sorting through data ever since. So that's really pleasing and really exciting.
And even on the actual, over that 25 hours at the end of it, you said, so we do by this discovery, there is some sense of the changing age of the universe.
That's right. These type 1a supernovae, they're called standard candles. They always go bang with the same brightness. So you can use them to measure distance. If you know the distance, you can measure the speed of the expansion. And so we put that one in the hopper with all the others. And there are probably a few, there's probably about 500 to 1,000 of these things that get used, depending on how you pick them, to measure the speed of the expansion. And ours is in there now, contributing to our knowledge of the age of the universe, because some of our viewers looked on a website and found the thing, and then we pointed a telescope at it and did all the rest as well.
So for those of you who are watching or listening who don't know about the whole Zooniverse world is absolutely fantastic. Chris has written a brilliant book about it, which I highly recommend. But it is that term that's used, citizen science, which is you don't have to be a scientific expert. You just have to have curiosity and interest, and you can get it isn't just about astronomy. It is about so many different areas of scientific research, and it really will give you a kick, I think, for a lot of people to get involved, to just feel I'm part of something. I'm part of trying to understand the universe. It's such a delightful project, I think.
Yeah, that's why I think we've been really busy during the pandemic, because people who have had time have wanted to feel part of something. And it is somewhat magical that you could go to a website and in 5 minutes contribute to finding, I don't know, a planet around another star, or counting penguins in the Antarctic, or whatever it is. So I think you do need about 5 minutes to chip in. But if you've got that, you can navigate your web browser over to zooniverse.org and contribute with everyone else.
Can I just check, by the way, so the age of is I remember the first books that I read was about 13.7 billion, 13.8 billion. What would you generally say in terms of the age of the universe?
I would say it's creeping up towards 14 billion is our best guess at the minute. But there's this discrepancy. So what cosmologists who study the universe as a whole are strange people, and they like to disagree, but they're very careful about how they describe their disagreements. So at the minute, the people who study the early universe and work out how old it is are disagreeing with the people who look at the supernovae that we discovered and use them to work out how old it is. So there's this slight difference between them, but they call it a tension in our understanding of the universe. So one of the big things that I think will happen scientifically this year next is there'll be this tension resolving itself as we get new observations, and then I'll be able to give you a better answer, maybe with as many as 2 decimal points, 2 numbers after the decimal point, and we'll know the age of the universe. But one of the remarkable things is that we know the age of the universe more accurately than we know the age of the Earth. And when you tell people that, they sort of don't believe you, but it's true. The error bar on the age of the Earth is larger. And that's not because astronomers are better than geologists, although some may say that was true. It's because the universe as a whole is simpler than the Earth. If you want to understand the universe as a whole, it's
we
just
have
physics.
That official. It's been said.
Yeah, sure. We do the easy stuff,
Helen. All the people who think that astronomy is, all the astronomers are the clever people and all the earth scientists are just messing about in the mud. He just said it. Did you hear that?
It's true. No. We picked the easiest problems, especially cosmology, where all you care about is the grand picture. You can write down all the equations you need on the back of a medium-sized envelope. To understand the Earth, you've got to worry about chemistry, you've got to worry about the geological processes. It's all very messy and frankly not that beautiful. Whereas cosmology is this beautiful picture that will just that's very simple. But it means that we can have this remarkable precision about what seem like the biggest questions of all.
I'll help Helen with this, by the way, just so he's saying beauty now, but I interviewed Chris a while ago where he said the problem with the universe is I've realised that it might be very, very boring because it turns out one patch of universe is exactly another patch of universe, whereas, of course, as you know, and one patch of some undersea murk, all the variety in it. So well, we haven't got time to talk about that. I'm going to come back to you for your show and tell because I want to bring in Lucie as well, just because another question that comes up from the 25-hour show was all about the solar orbiter slingshot that you spoke about with nine lessons. So what is the next stage is something that Kendall would like to know.
Yeah. So the solar orbiter slingshot around Venus happened on the 27th of December last year. And its role was to start to take the spacecraft to get closer to the sun than it currently is. And it's already, very close to the sun. So we've had pictures of the sun taken from half of the Sun-Earth distance, but that's not good enough for us. We want to go further. So in the coming months, the spacecraft is gathering some data about the environment about it, but it actually doesn't start its proper sort of science phase until the end of this year now. And that's because we want the spacecraft to be in the right part of its orbit. So there are future slingshots coming up that will, over time, in fact over the next few years, take the spacecraft closer and closer to the sun, but also will move the spacecraft from being in an orbit that's in the same plane as the planet. So, you know, it's launched from Earth, so obviously it picks up the characteristics of Earth's orbit, and we want to move the spacecraft orbit out of that plane so we can start to see the top and the bottom, the poles of the sun, which we've never seen properly actually ever in our, you know, 6 decades of space exploration, hundreds of years of telescopic observations of the sun. We've never seen the poles, and that might sound kind of trivial, but actually there's a lot of interesting information that we're missing because we can't see the poles. And for me, it all comes down to magnetism. So people who see me talk about the sun know I always obsess about magnetism, and magnetism is what gives the sun its character. It makes it, you know, variable, produces explosions, eruptions. And the way the magnetism sort of evolves on the sun can only really fully be understood if we can see what the magnetic fields at the poles at the top and bottom are doing. And we've never been able to measure those fields before. So, yeah, so what's coming up next is a sort of a bit more of the same, in the sense continuing to get closer in and then coming out of the orbit, the plane of the orbits of the planets as well.
See, that's always so interesting when you suddenly say poles of the sun, because we're so used to thinking about the poles of the Earth, and I think very often we don't think about that for other kind of celestial bodies.
Yeah, and it's been, I think, the case across the solar system that when you look at the polar regions, it's always like, oh my word, we didn't expect that. So I remember when Venus Express went to Venus, and one of the poles, so at Venus you've got these really fast winds that whip around the planet, and it's got a really dense atmosphere, carbon dioxide rich atmosphere, and so a vortex at the poles was expected because of these fast winds. And I remember at one of the poles, I forget which one it was, a double vortex was discovered, and that was oh wow, totally exciting. You know, let's think about the physics of what's happening in the atmosphere of Venus now we've discovered from this double vortex. And then at was it Jupiter? I think it was Jupiter. Chris might correct me if I've misremembered here, with the kind of hexagonal polar Saturn. Oh, thank you. So the hexagonal patterns in the flows at Saturn were a surprise as well. So I think, you know, polar regions of objects are really interesting, and you can't get that complete picture of the body until you've got that, you know, completely global coverage. And so for me, being able to measure and characterize the magnetic fields at the poles of the sun would be a massive step for us. It'd be a massive step for science, and it would also be a big step for this area of space weather, where we want to understand how the magnetic activity of the sun ultimately affects us here on the Earth. And we make models of the sun's magnetic field, but they're driven by data, and the models are incomplete because we don't have any measurements of the magnetic fields at the poles. And once we get that, even just with the snapshots of Solar Orbiter, that will help us understand the sun much more.
Brilliant. I'm going to come back to you for your moment. I've got one thing for Helen, which is being sent in to us, which is an article from 5 years ago in Vice, which was apparently trending on the front page of Reddit yesterday. So I'm sure you probably know about this, Helen, because it's in one of your specialist areas. And the title was "A Whale Blasted an Ungodly Amount of Arse Ham All Over Some Divers. The whale flipped onto its side and started spinning in circles while engulfing the divers in excrement, creating what one of the divers called a poo-nado." And lots of people have sent this to us, and they want to get Helen's basically your take on it. So what is your take on what was going on in that situation?
It's always nice. You know what people associate with you. Long ago, when I was a college student at college, I was environment officer of the college, and one day some people found a wheelie bin in a pond. They fished it out of the pond. They brought it to me and said, "Oh, we found this and we thought of you because of the recycling." But what I heard was, "We fished something out of a pond and we thought of you." And I actually could make use of it. But anyway, so this article, so it is 5 years old. Apparently this hasn't been observed since. What happened was a bunch of divers who were professional photographers were diving with whales in order to take very nice pictures of them, and one of the whales Well, we don't know what it thought about it, but what it did was sort of spin around in circles and very deliberately generate a cloud of poo. And one of the things about whale poo, as we have discussed, is that it's not necessarily in nice little lumps, although it can happen like that. It's very fluid, shall we say. It can make a gigantic mess. So what happened was that the whale spun around and made, quite deliberately, it seems, a gigantic poo mess around these divers and then cleared off. And so I had a nose around, and this was 5 years ago. There's been no other reports that I can find since of similar thing happen. The question was, is this deliberate behavior? Is this a whale deciding that it doesn't like it's a bit fed up of these humans, it wants to make them go away, and it decides it's going to poo all over them to make it happen? Or did it just have a bit of a bout of diarrhea, spin around a bit while it was doing it and then clear off? And there doesn't seem, from the time I've had to research it, there doesn't seem to be an answer. This behavior hasn't been filmed since. Whales are intelligent creatures. There is no way that they are not aware of the consequences of their poo. Because for a start, they will notice if they swim through another whale's cloud of poo. So we don't. I think the jury's out on whether it's deliberate behavior. It wouldn't surprise me if the whale was just mucking around, literally. But it doesn't seem to be considered a known defensive tactic, although whales are intelligent and perhaps they use it occasionally. But they're clever, right? They live in 3 dimensions. It wouldn't surprise anyone if it was deliberate, or at least deliberately annoying. Or maybe it thought it was playing. Maybe it was like, oh, I've got a toy, come and play with me. So we don't know. The jury's out.
I was just going to say, Robin, this is an example of the kind of difficult problem that cosmologists rarely have to deal with.
Yeah, I would. The
you haven't found Poo Nebula yet? Come on.
I'm sure somebody's named one, but galaxies move slowly, and as far as we know, don't excrete, so we're good.
Yeah, the nearest you get was it not Velikovsky? I'm trying to remember who it was who, the pooing out of one planet from another, I suppose, could some way in a Freudian perspective, but we'll deal with that another time. But we will keep you up to date, everyone watching throughout 2021, about our increased understanding of poonados. And it does give me a chance also to remind everyone that you really must see Helen's Christmas lecture. It was fantastic. Very little of it was about, I think about 38 minutes in, there was a little bit about whale poo, but it was a really brilliant lecture. But afterwards, my dad just went, I watched it with my dad, and he went, she's very good, isn't she? So, and he was entirely right. Let's start off with Lucie. What have you got for your show and tell for us?
Yeah, so I've picked something quite small, which is a medallion. So it's got NASA on one side, and on the other side, it's got a relief of the International Space Station flying around the Earth. And the inscription on it reads, if I can read it, it's very small. This medallion contains metal flown to the International Space Station. So I rather like this. Don't ask me what the metal was that flew to the space station. I don't know. But it was given to me by Charlie Bolden, who some people may be familiar with. So he was NASA administrator for about 8 years. And I thought he was a brilliant inspiration for a lot of people who are interested in space science, and the administrator Charlie Bolden sort of has another link to me. So he gave me this, but we also had a chance to get him to a school that I'm heavily involved in, and this is the UCL Academy in London. It's a secondary school, and we have a high number of disadvantaged students in the school. It's a very ethnically diverse area in London. And so I got an opportunity to bring him to the school. So I emailed the head teacher and said, oh, hey, the NASA administrator wants to come and visit, let's set this up. And she said, well, I don't think the administrator is really the best person to come along. I was like, no. The NASA administrator is the person who runs NASA. He was a 4-time shuttle pilot, distinguished astronaut. He was the first Black administrator, brilliant person. So after we got over that misunderstanding, we did get him into the school. But obviously the space station was a big part of his career. And so that, alongside the fact that we've just celebrated 20 years of continual living and working, having human presence in space because of the International Space Station, made me want to select this as my kind of show and tell object. Even though it looks quite small, I think it's of huge significance in terms of what it represents for human ingenuity, achievement, and all the messages of working together that we need at the moment. So I think that's rather special.
I think it's such an interesting thing, isn't it, that however theoretical anyone's work is, and however theoretical an idea seems, to have something tangible, to be able to touch, like, in a few weeks we're doing stuff on geology, and but anything, I think that sense of an object that has had a journey, or an object in which we know part of its story. I think that's such an important part of it. However many equations will justify something. In the same way that I remember talking to Jocelyn Bell Burnell about the first proper photograph of a black hole, and to her it means very, very little, because she's known they exist. She's been working on them for decades and decades. But for an enormous number of people, wherever they've read about black holes, to have that first photographic image is, again, it feels it's something tangible beyond our imagination.
Yeah, and I'm very into the tangible, definitely. And so, the place I work at UCL, which is a space lab, so there's people like me who are working on the data, collecting data, analysing data, but I'm also trying to be an advocate for the hardware, the tangible, and we would call it our material culture. So the things that you can touch and feel, that have stories associated with them, that people, imagined and made real and worked on and built and went into space and survived in those amazingly harsh conditions are really important. And I think we shouldn't forget that side of space science and space exploration. And I'm very keen that we then preserve that material culture for future generations. And that's why I'm interested in working with organisations like the Science Museum, because they allow us to collect those resources and tell the stories of those resources, and they can be also what connect to people and speak to people. And I often think it's kind of a shame that the amazing pictures are often what's always talked about, but behind the scenes, there are the things made of metal and what other materials, that have been built and have gone into space that have enabled us to get the knowledge that we've gained.
But there's actually there's a bigger thing there. Sorry, just quickly, because it was one of my beads in my bonnet about physics. So the reason I passed all my exams in quantum physics and cosmology, and I chose to do solid state physics because I could touch it and play with it. And I found it very hard. Like in a lot of years after that, we all talk about science. A lot of people say, "Oh, I'm not interested in physics," and you go, "No. What you're not interested in is the thing you hear about, which is stars and planets and things that are far away that you can't touch, you can't have a tangible relationship with." And actually, if you talk to them about the physics of the everyday world, they are interested. And so I've got this proper bee in my bonnet that we've actually labelled these subjects as, this is for you if you're happy to live with less tangible connection and you're happy to think about big ideas. But for the people who want to play with it, it's not that they're not interested in science. It's just that they want to see a physical thing that they can touch and play with. And I feel that they're left out because we've had such a sort of strong cultural, this is physics. It's stars, it's far away, it's weird quantum stuff. Thou shalt not play with it.
Yeah,
it's over there. And actually there's far more physics, as Chris said, all this complicated stuff. There is stuff you can touch and play with. And actually, so I shan't rant on, but I really think that matters. Those people do like science. It's just they don't like the science they've been shown because they want to touch it.
That's why I think that phrase. Chris.
Sorry, Robert, go on.
No, you, Chris.
Well, I was going to say, but even in astronomy, I agree with everything you've just said, Helen. But even in astronomy, there's sort of the material culture of like going to the observatories, of building instruments and so on. We've had, during lockdown in our building, the happiest people in Oxford have been the team building an instrument called Weave, which is heading to the Canary Islands, because it's got these long fibre optic cables, hundreds of them that will each take light from an individual star or galaxy. And they've been able to really get on with building their instrument because they could use the long corridors of our building to lay out their fibre optics because they knew no one else would be in there. And so that it really is this sort of culture of being there. I started as an astrochemist because I liked the idea of working with people who were in the lab down the hall who were trying to replicate the conditions that I was seeing with a telescope. So even the intangible subjects have this sort of materialness to them as well.
Yeah, they do. It's all happening. And it's, I think, us to talk about it, to convey that there are all these different aspects. And so I've sort of taken it, I've tried to change my mindset over recent years to make sure I talk about the stuff that you can physically hold and the people and the fun and the playfulness that goes into making a space mission happen.
I always think things like, I know Buckminster Fuller popularised the phrase, but it might not have initially been him, but spaceship Earth, that sense that we are not stuck and that we are moving. And all of those people who, those wonderful explanations of where different elements come from, and the air, the rare an element, the processes required in the stars, all of those things I think are great for creating some kind of sense of the tangible. I'm going to ask you actually, Chris, before I get to your show and tell, because you were just talking about that journey to the observatory, Brianna wanted to know, what do you think will fill the gap left by Arecibo?
Well, hopefully Arecibo too. So people will know that the great Arecibo observatory collapsed rather catastrophically just at the end of the year. And we have other big radio telescopes. In particular, the Chinese have a new single dish, and people are building many things. But Arecibo was unique in that it could do radar as well. So you could actually transmit with that observatory, and they use that to do things like look at the shape of near-Earth asteroids. So you can bounce radio waves off bits of the solar system and get information you can't get any other way. I'm reasonably hopeful that the Americans will invest in Puerto Rico, which is where it is, and build another telescope. There's certainly a lot of use for big single dish radio telescopes. Most of the modern radio telescopes we're building, like something called the Square Kilometre Array, these are arrays of many smaller dishes that you add together to give you the power of a large dish. But sometimes you just need the Jodrell Banks, the Arecibos of the world, the big single dish. And with new instruments, that could be a remarkable facility. And I think that will happen.
Lucie, we've just had a question from Zap Fan. This is a live question, which I have to do this because I'm very old. I have to lower my glasses and work out where the light's right. What did the Ulysses spacecraft tell us about the poles of the sun?
Oh yeah, Ulysses, amazing mission that flew over the poles of the sun. So I was talking about that for Solar Orbiter, and I said we've never seen the soles of the sun. The pole, that's a different program. The poles of the sun.
We're just going to take that bit though, and because I think that could woo in some of the people that we were hoping to build a cult around this, because I've heard there's a lot of money in cults, and the soul of the sun I think is a good starting point. Be ready to be a priestess.
I could make some money that way. So the poles of the sun we've never seen with images, but we have flown over with the Ulysses spacecraft, and Ulysses then measured the outflowing magnetized plasma from the poles of the sun. And Ulysses flew for, I think it made 3 passes over the poles over a couple of decades. And it allowed us to measure the material coming away from the sun from those regions. So we could get the magnetic field information because it's a magnetized plasma. We could get, say, the velocity of the plasma. And because it did 3 passes separated by about 10 years, we were able then to see how these outflows changed over time, over the solar cycle, in fact. And so in these data sets, Ulysses showed us how the magnetic field of the sun kind of pulses and changes in strength and complexity, and how these streams of wind from the sun go from being not very complex at the minimum of the cycle to being very complex at the maximum of the cycles. This Ulysses was an amazingly important mission, and Solar Orbiter will build on what Ulysses showed us.
Brilliant. Thank you very much. Thank you for that question, Zapfan, as well. A quick question for you, Helen, which is from Melanie. Melanie just wants to say that the whole family absolutely loved all of the Christmas lectures, and was intrigued to know that you mentioned on Twitter there was so much that you wanted to cover but had to skip because of time, and just wondered if you could tell us a couple of the things that you would most wish you could have squeezed into that Christmas lecture.
All of the rest of the ocean, but I'm writing a book about that. Well, I will be once the teaching admin associated with COVID has gone away. The 2 biggest topics that I didn't include, that I do feel guilty about, but I put as much in an hour as I could, are the poles and the deep ocean. So the poles of the planet, especially the Arctic, because that is actually an ocean, is a massive part of the system. In the same way that Lucie was saying the poles of the sun are important. The poles of Earth are really interesting because one is an ocean surrounded by land and the other is land surrounded by an ocean. But the ocean in those areas is really fantastically important. It feeds everything else basically because of the temperature difference. Temperature and buoyancy, as I showed in the lecture, buoyancy makes things move in the ocean. So the poles are really important kind of feeders, and the Arctic Ocean also, it doesn't directly connect in the sense of it helping things travel across between the Pacific and the Atlantic, but it feeds down through the Bering Straits and through around Greenland. So it's kind of feeding down on the two sides of the planet. So the poles, like not including polar oceans, is something I feel fantastically guilty about, but I can't do anything about it. It's going to be in the book. Let it go. And the other thing is the deep ocean, because, and it's weird. And the reason I didn't want to talk about the deep ocean is because we have such a limited sort of, general view of the ocean. If you ask people what's in the sea, they'll say fish, they'll say there's some weird stuff at the bottom, there's some black smokers, and then the rest of it's kind of empty. And so I chose not to include the deep sea because it's already been seen a little bit. All the interesting stuff that's happening in the middle, people don't talk about. So the deep sea itself is important for the engine on top of it. It's not just a place where, bits fall down and pile up and then they sort of accumulate there until they get shunted into the continents. It's actually important for ocean mixing and how temperature, there's these, it's really hard to talk about without diagrams, but so water in the ocean tends not to mix. It's too big. These layers, like when you pour water in the bath, sometimes you can feel it's warmer at one end for a bit before the warmth gets to the other end. So even your bath, something the size of your bath, doesn't mix perfectly because those two ends stay quite separate until you start mixing the bubble bath in or whatever. So in the ocean, water masses don't mix, but there are shapes in the deep ocean where the ocean, for example, if it's flowing sideways very slowly and it passes over a seamount or over a bumpy area where it sort of generates turbulence and you get this region of mixing. And actually, that's really important for how the engine of the ocean works and how heat is transferred around the ocean. So I think leaving out the deep sea and all I think we had it when Helen Scales joined us a few weeks ago, and she said, there's a limit below which fish can't live because the pressure is so great that they would basically poison themselves, give themselves oxygen poisoning because their bodies, they would, at that pressure for them to have enough oxygen, it would also be poisoning them because of how easily it would move into their tissues. So yes, the poles and the deep ocean were the two biggest things that I feel guilty about, but there are quite a lot of others as well.
Another 25-hour show, you can have at least half of it, so hopefully you can cover that. Chris, I'm going to go into your show and tell, but just before that, Caroline wonders if you could help her daughter find the constellation Leo in the night sky.
Sure. So Leo is actually quite distinctive once you've got your head around it. So it's supposed to be a lion, but the thing to look for is a backwards question mark. It's sometimes called the sickle. So the bright star Regulus is at the bottom, and then there's a backwards question mark, which is sort of like, it's supposed to be the head of the lion, but think of it as the tail of a mouse, and you'll be there. So there's a backwards question mark and then a triangle. At the minute, it's rising around midnight in the east, but if you wait a few months, it's a sort of late spring evening constellation. Look east, look for the backwards question mark, and you should find it from there.
Brilliant. And let's have a look at your show and tell then.
Yeah, well, it's actually linked to what we were talking. We were talking about touching and tangibility. And I was talking to somebody over New Year about the fact that there's no astronomical significance of 1st of January whatsoever. We have the winter solstice, which is astronomical, but 1st of January is just an arbitrary date to astronomers. And then we got talking about the galactic year. So you're talking about the Earth moving through space. Of course, the sun moves too. And we take about 240 million years to orbit the center of the Milky Way. And so 240 million years is a galactic year. And I started wondering how one could experience that. You don't exactly wait between galactic New Year parties. So I looked for old things I had in the house. And this is actually what I came up with. So this is a chunk of rock from Lyme Regis on the south coast with an ammonite, which you can see. This is where Mary Anning and co did her collecting. I picked this one up off the beach a few years ago, but this is from the Jurassic. So this is about 180 million years old. And so I'm now holding something that's 3/4 of a galactic year old. And that is in itself a little less than 1% of the universe in terms of age. So that's the scale. We're talking about 14 billion years of cosmic history, and we've had just over 100 galactic years, and almost one ago, the south coast of England was a warm sea with pliosaurs and ammonites and all the rest, and we can touch that. So that's as close as you get to being able to feel cosmological time.
That's brilliant. You mentioned Mary Anning. is a campaign at the moment to get a statue for her, and go on have a look at it, because they're getting very, very close, I think, to their target. So I forget the actual name of the campaign, but if you put in Mary Anning statue, it won't be long before you find the correct site. And just so the quick mention as well before talking of metal that's been to the ISS, I was saying there's something coming up 2 p.m. on Tuesday afternoon for all Patreon supporters. I'm going to be talking to Nicole Stott, who is an ISS astronaut and now does really interesting work with other astronauts as well about using art to engage people in ideas of space exploration. And she's been on Infinite Monkey Cage. She was on the last one that we did with with a bunch of astronauts, and she's great. She's such I interviewed her a while ago for the book that I'm working on, and she's always so intrigued. But if you're a Patreon supporter, you can watch the live conversation that we're doing at 2:00 on Tuesday afternoon. That's 2:00 GMT, in case you're watching anywhere else in the world. Helen, I'm going to come over to you in a moment, but I've got one more question that Barry would like to know, Lucie. Would like to know if you took the week off after coming up with the closing of your nested loops. Can you tell us a little bit about this?
This is someone who is very astute and perhaps follows me or my other half, Matt Parker, on Twitter. So over Christmas, it was Christmas holiday, but we had a day where we both found ourselves doing some coding. So I used a piece of software called IDL. Matt was coding in Python, and just in the evening over a glass of wine, we were talking about how our coding had been going in the day, and we were talking about nested loops. And I don't know, we just got talking. And so if you've got a loop within a loop, on that particular day, so my first loop was, do something from I equals 0 to 9, do this thing. And then within that loop, I had another loop, which was, and I called it from I equals 0 to 9, do this thing, for example. Whereas Matt was like, no. I don't know if I've lost most people by now. My first loop is I, and my loop within the loop is J. And he tweeted about it and got a lot of opinions, shall we say, about how you should name your loops within loops, and it even appeared on Reddit as well. So it's just this thing that this little conversation we were having over a glass of wine kind of blew up. So I've even forgotten the question now.
So what was the consensus? Because I was really interested in this, because I think, like a lot of people, I'm basically, like, I do a lot of coding, but I'm basically self-taught, right? A lot of what I do, I had to look up at some point, and then I kind of worked out how I was going to apply it for me. So I use IX and IXX and IX. This is a labeling convention, but I don't know where that came from. Is there a proper way to do this? Like, I mean, what did you find out?
Yeah, so a lot of people would say, like they said, I was taught to do it such and such way, but I'm like you, Helen, I just taught myself. So, we did some stuff at school, but I cannot remember that. And I don't think we did much at university. So it's basically, the classic in research, in academic research, you have to figure out how to do it yourself. So my convention just comes from one that I find intuitive. And I didn't get a sense of there being any particular accepted convention. So everybody had their own opinions and their own ways of doing it, which I guess was nice, because it just goes to show you do what works. And there is a kind of, logic and a way of programming, but ultimately you do what works for you and what's intuitive for you. So, which I kind of like. I mean, it was hilarious. It really was.
Of all the things that you can have Twitter spats against, I feel that's one of the more positive when I see what's been going on over the last week. The next question is from S. Weber, who would like to know, and this is something I as usual, nothing about. One of the criteria for a planet is that it's cleared its orbit of debris. So why is Jupiter a planet with its Trojan asteroids, Chris?
Well, this is all to do with when we were all upset about Pluto and whether Pluto should be a planet. And it's not a planet, let's be clear. It's a dwarf planet, and it's very happy, and that doesn't make it less interesting than if it were a planet. But the criteria they came up with is that you have to orbit a star, you have to be round, which is actually a constraint on size, because once you get above, or mass rather, once you get above a certain mass, then gravity will force you to be roughly round. And then there was this extra criteria tacked on, which said you have to have cleared its orbit, or rather, the way that's interpreted is that you sort of have to be clearly the most important thing in your orbit. So Pluto's orbit crosses Neptune. There are also a whole bunch of other things out in the Kuiper belt. And that's really where the problem is, because the logical positions are either that we have 8 planets in the solar system, because there are 8 things that are obviously distinct on these and other criteria, or you have to have about 200. And both of those are perfectly logical, but we didn't fancy learning 200 names. But the Jupiter Trojans are fascinating. So these are asteroids that orbit the Sun, but they're in roughly the same orbit as Jupiter. And a bunch of them precede Jupiter around its orbit, and a bunch of them follow. And there are those 2 places where there are stable clouds of asteroids. And we don't know much about them, but we think they're captured into those orbits because they've been particularly unlucky. But they may contain, it's sort of like looking behind the sofa. You find the debris that tells you about what's happened in your house over the last, let's go with years, shall we? It depends on the house. The Trojan asteroids preserve the history of the solar system. And there's a mission called Lucie, which is being launched later this year with any luck, which is going to go on this long tour of the solar system. And it's going to dive through the clouds of Jupiter Trojans and observe them up close for the first time. So they're fascinating things. But to clear your orbit, you don't have to have absolutely nothing there. It's just that you have to be obviously the largest thing, and then you can be a planet.
How wonderful to know about our planet, Raj. What an ego. I always thought Jupiter had an ego. Can you just, mentioning dwarf planets, this is something not over. How many do we believe are in the solar system now, approximately? What's the rough estimation? A
dwarf planet, so things that meet all of this criteria, I think there are 4 or 5 that we know meet those criteria. There are probably a couple of hundred in the Kuiper belt, and we're still discovering them. The difficult bit is that because we've set the rules so that they have to be round, when you have something on the outer solar system and it appears as a point of light, it's quite difficult to study it in enough detail to check what its mass is and what it would look like. But there are probably at least a couple of hundred things roughly the size of Pluto in the Kuiper belt.
Brilliant. And Lucie, one for you, based on a tweet that someone. By the way, we've got 20 minutes left. I'm going to try and get through all these questions. I'm going to try very, very hard. One of them is about milk frothing, Helen. I reckon there's no way we're going to fit that one in, but we can always follow that up next week. But Lucie, this was a question about room 715. Saw you mentioning flux ropes and says, try to do some Googling, but quickly got out of my depth. I wonder if you might be able to give a simple explanation of what a flux rope is.
Yes. It warms my heart to know people are thinking about flux ropes, because this is a sort of magnetic field configuration that I study in my research. So I'm coming back to magnetic fields again. So if you imagine magnetic field shapes, and we can use the concept brought in by Michael Faraday to say that if you have a magnet with a north pole and a south pole, a magnetic field line going from north to south makes an arch between those 2 poles. And in the sun's atmosphere, we have lots of those magnets around the surface of the sun, say, with arched field lines going from one to the other. So if you look at any images of the sun's atmosphere, you'll see plasma emission structures tracing out those fields, and you'll see they look like arches. But in a magnetic flux rope, it's as if you took a bundle of arches and twisted them so that they then are helical. So it's like having a piece of rope that's got a helical structure. So a magnetic flux rope is a twisted bundle of magnetic field lines, and they're important because they store energy, they produce eruptions and so on. But a flux rope is a twisted bundle of field lines. Great question.
Brilliant. Thank you very much. And this one for you, Helen. Terry would like to know, Carl Sagan said we're all made of star stuff, and you said we're all made of poo. Which is it? So, of course, it can be both. And from this as well, if you'd also like to go in and I know you've got a little bit about the history of science you'd like to talk about. So let me hand over to you.
Well, that depends on timescale. As with many things in science, you have to define your frame of reference. So on scales of, possibly up to the age of the Earth, probably ultimately we're all made of poo, in the sense that we're all made of the waste of something that was something else before. And so when I was talking about poo, I was mostly talking about the organic world, even though inorganic things go round and round as well. So on human timescales, I would say we are all made of poo. Ultimately, the poo's had to come from somewhere. It's like poo's all the way back, right? The thing was made from the poo, which was made from the other thing, which was made from the thing before. So ultimately, it's like turtles all the way down. It's poo all the way back until you get to the atoms that made up not just the first living things, but our planet. And that's when you get back into Carl Sagan and the stardust. And so I guess, and I was using the word poo rather loosely to imply something that was something else before. So in our organic world, yes, it is quite literally poo generally that goes round and round, but we are also made of stardust. But obviously that you can't imagine Carl Sagan's voice, can you? Looking out over the starry, the galaxy view, talking about poo. It's not his kind of word, really, is it? So they are both true, but ultimately the poo all the way back starts in stardust. So then my little bit of history. So as Robin said, we are running. I'm lucky in that I've got a lot of interesting things in my flat, but I feel I've shown everyone the best ones now. So this year, what I'm going to do is, however long we're going on for, is a bit of history that happened this week. And actually this week I picked something that happened on January the 10th in 1947, because it's very relevant to what's going on at the moment. And it was the isolation of the polio virus. And the reason I pick up on it, that was when it was announced, is that there wasn't an effective vaccine. So that was in 1947, no effective vaccine until 1955. And that was with a virus that was very simple to isolate. The mechanism of making the vaccine was quite well known. it was developed in rats, I think, and developed on. And the reason I mention that as a piece of history is, firstly, none of us know anyone with polio, right? It has almost vanished, and it almost vanished. I think there were like 300 cases last year. It vanished because of vaccination. And the other thing is that, just to go to the sort of serious COVID stuff, is that it blows my mind that a vaccine is available so quickly and can be scaled up. Like when you talk about, like, whatever you think of government competence or incompetence, the idea that within a year the scientific enterprise has not just developed the vaccine, it has made millions of doses of it and has got them to people. Like, the scale of that achievement is just, we cannot take that for granted. It's mind-blowing. That is a civilization scale achievement that has never been possible in history. So my little thing about 1947 and the polio vaccine is just because it was a special moment, but just to appreciate how quickly things have happened this year, and how the idea of scaling that up, because it took decades to vaccinate enough people to make polio go away, absolutely decades. And, so it's a reflection on what's happening at the moment, because however much we all want these vaccines to be available faster, the fact that there are millions of doses at all, the logistics and the science and the engineering is just astonishing. And it was people that made it happen. And so, yeah, that's my thing this week.
Thank you. And I should say, I think we'll probably need to do Q&A at some point, which we normally do is separate to this, and depending on Trent's availability and stuff like that as well. I think maybe on a Sunday night. So if there's any particular, not really questions, but if there's also any particular areas of expertise that you would like us to try and focus on, we'll try and put together the best panel possible just before Christmas during the 25-hour show. We had a great panel which included was Emma Hodcroft and Dan Davis and Kevin Fong, who's actually been dealing day to day in hospital situations with what is going on. And if you get a chance, that's on the Genetics Unzipped website, and it's also on YouTube somewhere. I can't remember actually what tag it's got there, but it's got a panel with all of those people on, and Kevin in particular, as someone who has been working for so long within the hospitals and is, like so many health workers that you might know as well, not merely having to deal with something with an incredible amount of pressure, a great deal of jeopardy and anxiety, but on top of that as well is having to deal with people abusing and seeing what is actually going on in the hospitals. And so I do hope that all of you have found good sources to find out what is really going on, because there's a great deal of irresponsibility going on about COVID-19 and what some of the things we're seeing on social media and in the popular press, where irresponsibility is dressed up as some idea of free speech. But do if you get a chance, listen to that Genetics Unzipped. Now let's get on to the sun. Now I'm going to start with you on this, Lucie. This is from Carol in David Attenborough's new series. He said that almost every spot on Earth receives the same amount of sunlight as any other place every year. And Carol Base says, really? And I presume this ignores the poles. So how true is that?
Yeah, I guess I probably wouldn't describe it that way. So, because if you imagine you're kind of lighthouse beam of light coming from the sun to the Earth, what's falling on not necessarily the equator, but the bit of the Earth that's kind of sticking out most. It's hard to do with.
I've got a hang on.
Have you got an Earth?
I haven't got a globe. Whoops.
Oh, there you go.
She's fallen over a globe.
Sphere.
Terrible January globe accident.
Yeah.
Sphere. So what we've got is lines hitting. So if you talk about the equator, Lucy.
Yeah. So the middle bit of the Earth receives kind of like the full brunt of sunlight, but as you go to a higher latitude, say, that same amount of sunlight beam that's coming in spreads over a larger area, so the energy is more spread out, so the flux of light is different depending on where you are on the Earth. It's higher
the difference, I actually do know the numbers, so I think coming from the sun at the radius of Earth, it's at 1,343-ish watts per square meter, and the average for every meter on the surface is 343, but as you say, at the poles that goes to 0. So yes, and also there's clouds. Some places in the world are more cloudy than others, and so yes, it does sound like quite a lot of a simplification.
Yeah. Which may be fine. I simplify all the time in astrophysics, and I round up numbers to the nearest whatever order of magnitude I'm interested in at that point in time. So we forgive him for doing that, but it's always more complicated than that, isn't it?
Well, I always think that's one of the important things with so much kind of science broadcasting, is to remind people that this is a start. An idea particularly interesting, don't immediately just go, oh, that's entirely true. There are so many ways that you can access very knowledgeable people, and you can go, oh, I see, this is kind of this as you said, this is a broad idea, but you can investigate it more. And that's the thing, is be active with the information that you're given as much as possible if it's something that really fascinates you.
But it is also the case that if it was stated as she said, if that was the exact wording, it was incorrect and it was a mistake and it shouldn't have been broadcast. I mean, it is the job of science broadcasters not to broadcast stuff which is too simple. So
yeah, that's true as well. Do you know, because it's not a verbatim thing, and I haven't seen the show, I can't be certain on that. Before you know it, we'll get back to the aquatic ape hypothesis, and we remember how much trouble there was there when David Attenborough did the radio show about that. I still enjoy the aquatic ape hypothesis. It gives me all manner of strange dreams and nightmares. Chris, this is from Gillian, who would like to know, will the James Webb Telescope primarily be collecting data, or will we get epic new pictures from it too, like Hubble?
I'll get to that in a second. If you don't know, Robin, about the space ape hypothesis, you should go and look that up, because it's a equivalent of the aquatic ape hypothesis, which explains why we clearly evolved in space. I think probably written with tongue in cheek, but you'll enjoy that. On James Webb, no, James Webb hopefully will launch this year. We've been waiting, well, my professional lifetime for this telescope. It's a imaging instrument, so that we will get data, we will get spectra, and we've just had the first set of allocations of time to astronomers, and people are very excited about the spectrographs, but it will take images. They'll be in the infrared, so it's very different from Hubble, which it's sometimes described as a successor to, which worked in the ultraviolet and visible light. James Webb is an infrared space telescope, so we will see different things, and we will see different places, like the coldest bits of the universe, the places where stars are forming, distant galaxies, that sort of thing. But it is an imaging instrument, and we will get spectacular pictures from it, as well as all the data, which will be exciting. But first it has to launch, and then it has this terrifying procedure where its mirror is too big to fit in the rocket. And so after launch, the mirror has to unfold and lock into place. And if you think that's a precisely machined optical surface, it's got to work perfectly. And so for the first month after launch, I don't think any astronomers will be capable of doing anything other than checking refresh on the NASA feed and making sure that all is well. So fingers crossed that will be the end of this year.
I wonder how much more badly beyond the Earth's atmosphere, a mirror, and if it gets broken. I'm not entirely sure which scientists have investigated that. Sarah or Sarah, I apologise, there's no H on, and I know some people will say Sarah and some will say Sarah, but she has a question which is a lot of people, again, always wanted to know this, and it's a good question, which is, where's the best place to start looking for a telescope, and for any, and I know you may well also say binoculars are a good place to start in terms of trying to get something on a budget.
Yeah, always start with binoculars because that gets you out under the sky. And the great thing about binoculars is you can just pick them up and go and look. Really, the best general advice is to contact your local astronomical society. There's a long list online, and those will be people who will know stockists in your local area and in normal times may let you come and have a look. The rough rule of thumb is don't buy anything that has a lens smaller than, this is imperial, 3 inches across, or a mirror less than about 6, and pay attention to the tripod. So people, one way, if you get a cheap telescope, they've often saved the money by the tripod. If you've got a wobbly tripod, you won't find anything. But really, talk to people who know. Find a local stockist or a local astronomy site and tell them what you want and take advice that way.
Eileen, can I just say now, I'm afraid we're not going to experiment question, but because Helen's on every single week, we will definitely find time sometime in January, hopefully next week. I'm going to kind of conflate Phoebe and Len's question. Phoebe would like to know where the world is at with regard to satellite regulation legislation, and Len would like to know a discussion for amateur stargazers about how to respond to the threat of mega satellite constellations like Starlink. So, Lucie, do you like to start?
So I think there are important conversations we need to have now, because we have legislation about what activities can be done in space that was set mostly several decades ago about peaceful use of space and how that's defined. I would say they are not fit for purpose today. And I think there's a kind of different way of framing the question. So it's not just about, who owns space and what you can do with space, but a slightly different way of thinking about it is who owns the night sky? And that's the question we need to think about now with these mega constellations. So these are constellations of thousands of satellites in orbit around the Earth to, for example, provide global internet coverage, which sounds really laudable. I think brilliant. Yeah, people in every part of the world, rural areas getting access to the internet, so important. And we've seen that more and more during the pandemic. But the sort of other side of that is that then these satellites are in fairly low orbit, say 500 kilometers up. So at certain times of the night, they will reflect sunlight and you'll see them whizzing across the sky. And I've stood in my garden and watched the Starlink satellites go over, a train of them, one after the other. So there's a lot of work now to be done around minimising the impact, finding some way of a compromise so that you can get the services people need, that businesses want to operate, that governments want to have in place, but you don't ruin the night sky. So the Royal Astronomical Society are looking at this. I would say keep the conversation up, speak to people about it, raise awareness of the fact that this is coming, and in fact it's already here. And I would like it to be that a company who does pollute the night sky in that way feels a reputational damage for polluting our night sky. So there's different angles. There's legislation that needs to come in, and there's a kind of public awareness that means, well, we will support companies who do the right thing by keeping the night sky open for everyone.
Thank you, Lucie. Chris, can I ask you a different question just because I want to try and get through all of them? Someone wants to know about this week's triple conjunction.
This is Jupiter, Saturn, and Mercury. I think low in the west just after sunset. Be beautiful, but it's very low down. So you need to be high up with a clear horizon just after sunset, and look for Jupiter and Saturn. And then if you're sure the sun is below the horizon, use binoculars to look for Mercury. But don't get your binoculars out until you're sure the sun is out the way.
Question. Darren would like to know if you had the money for only one trip, Enceladus or Titan.
Oh, they're both around Saturn. You could go to both.
Lucie?
I would say Titan, because that was really the first time I realised a moon of another planet was more like an Earth itself. So I'll go for Titan.
And final question, Graham Stewart would like to I read that the rotation period of the sun is about 24 Earth days at the equator, but a much longer 38 days at the poles. Is this correct? And if so, can you explain it?
It is correct. The sun is a fluid, it's a gas, it's not a solid object, so it's not constrained to all rotate as a solid body. The gas at the equator whips around much faster than the gas at the poles. And that means it stirs up the magnetic field. See, I get magnetism in every time I can, and that leads to lots of interesting effects. So it's because it's a fluid. There's a much longer answer behind that, but maybe I don't have time for that today. But it is because the sun is a fluid that it's free to rotate more quickly at the equator than at the poles.
Thank you so much. Chris, I know you're doing a talk tomorrow at 7:00, based at the kind of Armagh Observatory. And people just go to armagh.space, is that right?
That's it, yep.
So Chris, tomorrow night at 7:00. I should also say at 4:30 tomorrow on Radio 4. There's the first of the new Infinite Monkey Cages. It is a very rude show about flies. I have no idea how rude the 4:30 version is going to be. I would very much suggest you go and listen to the BBC Sounds podcast version, slightly longer version, but it was far more lurid than we imagined. I'll also mention quickly again, on Tuesday night at 8:00, I'm going to be doing a talk about ghost, death and physics. Two of my major texts I'll be using are The Osborne Guide to the Supernatural World, which will be popping up in that, and also John C. Lilly, who did a lot of experimentation with dolphin communication. For some reason, I've worked out how to get that in there as well. That's 8:00 on Tuesday night, and at 2 p.m. On Tuesday afternoon. If you're a Patreon supporter, then I'll be talking to Nicole Stott for a new series, so you can watch the live conversation about that. Lucie, is there anything you would like to mention coming up?
No, I don't have anything on my checklist to mention. Just keep up to date with the news. Get out and just have a look at the night sky. Nothing to plug.
And we should mention Sky at Night is January 17th this month as well.
It is.
Helen, anything you would like to mention before we go?
Don't think so. Yep.
Great. No, everyone's happy. Good. This is there'll also be a new episode of Uncanny Hour is coming up, and we're doing Deathline, the cannibal classic with Donald Pleasance and Christopher Lee and various others with Reece Shearsmith and Gary Sherman, the director of that film. That will be available for you on Friday as well for Patreon supporters. And have a great week. And as I said, we're going to try and do another COVID-19 one. Do look back if you get the chance to the conversation we had with Kevin Fong and others back in December. Thank you very much to our producer Trent Burton, and hopefully next week, by the way, I think we're going to be doing the natural world. We're going to be what you can find in nature at the moment if you're going out for walks, stuff like that. I'm not entirely sure what guests we're going to have, but start getting your nature questions ready. Bye-bye.